Let's look at a couple of examples of the indeterminate case 0 times infinity. So I've got this first one here. I've got the limit as x goes to 0 from the right of x squared log x. Now you notice that the limit as x goes to 0 of x squared, of course, is 0. And the limit as x goes to 0 from the right of log x is negative infinity. So we have this case where we have 0 times infinity. And the fact that it's negative infinity doesn't matter. So let's see how we would approach this. Now, remember, L'Hopital's rule calls for us to take the derivative of the top over the derivative of the bottom. And you might notice we don't have a top and a bottom here. So there's a little trick we can use. We can take the limit, the same limit, but write it a little bit different. In other words, we have log x over 1 over x squared, like this. Now, notice, dividing by 1 over x squared is the same as multiplying by x squared. See, I could invert and multiply. In other words, these are the same thing. I just changed the way it's written. So let's see what we've got now. We've got the limit as x goes to 0 from the right. Okay, and now one of the things, this is x to the negative 2, remember. So here's what we've got. Up top, the derivative of log x is 1 over x. Now let's see here, this is x to the negative 2, so the derivative would be negative 2x to the negative 3, right? See? Subtract 1 from the negative 2 and get negative 3. So let's see what we have now. Let's just do a little bit of simplifying. We've got the limit as x goes to 0. Up top we've got 1 over x, and on the bottom we've got negative 2 over x cubed. Now, we need to simplify this. So let's think about what we can do. Maybe I could multiply the top and the bottom by x cubed. Just multiply the top and the bottom by x cubed. And let's see what we have now. We've got the limit as x goes to 0. Up top, I've just got x squared. And on the bottom, I've got negative 2. Okay, so we did notice we implemented L'Hopital's rule, derivative of the top over the derivative of the bottom, and then we put our algebra skills to use and simplified it. Now you can see, this limit is clearly 0, right? Because if I just put a 0 in for x squared, I get 0. So that's that limit. Now, let's look at a different one. Here is another example where we have the limit as x goes to pi over 2 from the left, and notice that this is, if I plug in a pi over 2 in here, I'll just get 0. And over here, secant, as x goes to pi over 2 from the left for secant, it goes off to infinity. So we have this situation where we have 0 times infinity. And you might want to remember the graph that secant has asymptotes at pi over 2. So let's see what we could do here. Now, remember, what we're worried about before we implement L'Hopital's rule is the fact that there's nothing on top and nothing on bottom. I mean, there's nothing on bottom. We don't have the derivative of the top over the derivative of the bottom. But recall that this is an easy fix if you recall that secant is just 1 over cosine. So why don't I write it this way? Instead of writing secant up top, just put cosine on the bottom. 1 over cosine secant, same thing. Now, let's see what we have if we do this. Now, notice now we have the situation where we have 0 over 0. Up here it started off 0 times infinity. Now with that little bit of change, now we have 0 over 0. Okay, so just another indeterminate form. Now I take the derivative on the top. And remember, always carry your limit along. So the derivative of the top is just going to be 2, and the derivative on the bottom is negative sine. Oh, I put a 0 there. That wasn't right. Let me I was talking, got carried away. Pi over 2 left. There it goes. Okay, so now if we put pi over 2 in here for x, the bottom just becomes negative 1, and we get 2 over negative 1, which of course is just negative 2. So there's an example how we can use L'Hopital's rule for the 0 times infinity case.